Okay, welcome back, students. Now, in this discussion, we are going to discuss the basic technique of differentiation. All right, so let's start with some revision first. Now, in the previous discussion, we learned about the limit. So, what is the limit? The limit is actually the behavior of y. So, this is the y. All right, so the behavior of y when the x approaches to a value c. So when x approaches to value c, now what happened to y? Now if the y is approaching L, then we say the limit of the function is L when x approaches to c. All right, so and we also learned the basic definition of differentiation. The differentiation is actually a process to find the slope. So you can see this is actually the slope, all right, the difference of y over the difference of x. So it's a process to find the slope of a curve when the difference of y, which we call that delta y, all right, the delta x, all right, the difference of x, the delta x, all right, is as small as 0. So we use the concept of limit. Now, so it says that the limit of difference of y over the difference of x, which is the slope, when the difference of x is approaching to 0. All right, so to find the difference of y, so we are going to take, all right, y1 minus y2. Okay, so this is one y, this is another y, over the difference of x. Now we call this the derivative. So from here, let's move on to learn some basic differentiation technique. So at the end of this chapter, right, you need to know how to find the derivative of a function using the constant rule. All right, and number 2, you need to find know how to find the derivative of a function using the power rule, and find the derivative of a function using the constant multiple rule. So there are 3 differentiation rules here, right? We are going to learn under this topic. Okay, we are going to start with the constant rule. Now the constant rule says that if we differentiate a constant, all right, we always get 0. Now what does that mean? It means that, all right, the constant is the element in the function that without the x. So you can see, right, no x here. So since if we have a function which is a constant only, all right, so it will be a horizontal line. Okay, so what is the slope of the horizontal line? The slope of the horizontal line is 0. And right, from the previous discussion, we know that the differentiation is actually the slope. Therefore, right, the differentiation of a constant, right, which is a horizontal line, is 0. Okay, so these are some examples. Now, if we have the function a, b, c, d like this, right, first, if the function y equals to 7, so when we differentiate, since this is a constant, we will get 0. All right, for b, if fx equals to 0, so this is the function is 0, is a constant, and the derivative, right, will f prime x will be 0 as well. All right, so for c and d, as we can see, there are no x, right, for the no x appeared for the function. Therefore, right, when we differentiate, we always get 0. So this is about the constant rule. Now the second rule we are going to learn is called the power rule. Now the power rule says that if we have a function like this, fx equals to x to the power of n. So when we differentiate, right, so we are going to bring the n, this n, we are going to bring down. Okay. So when we differentiate, first we are going to bring the n down, this n power, we bring it down, and we copy the x, and what happened to the power? The power will be reduced by 1. All right, so we call this the power rule. Okay, let's see some example. Now, if we differentiate x, we get 1. All right, according to the power rule, y equals to x, the power is actually 1. So when we differentiate, according to the power rule, we bring the 1 down, right? The power we bring down, okay, and the power reduced by 1. Therefore, 1 we bring down, we copy the x, and the power is 1 reduced by 1, and we will get 1 x to the power of 0. And x to the power of 0 is 1, therefore we have 1 times 1, which is 1 only. Now, if we try to understand the situation, now we know that the function y equals to x is actually a straight line. Okay, so what is the slope of this straight line? All right, the slope of this straight line is actually 1. Okay, we can actually take 2 points from here. All right, 1 point, 2 points, okay, to look for the slope. All right, so we have 2 minus 1 over 2 minus 1, so the slope is actually 1. All right, and differentiate x is actually the slope of the function, therefore the answer is 1. Now here are some examples where we can use the power rule to find the derivative, and these are the slope of the functions. Okay, for the first function, fx equals to x to the power of 3. So when we differentiate, right, so the derivative f prime x will be, first we bring the 3, this 3 we bring down to multiply, we multiply the power, and the power reduced by 1. Therefore, we have 3, then x squared. Right, now for b, now to differentiate this one, first we need to change this to the index form. So what is the index of this one? All right, it will be 1 over 3, right? The power is 1 over 3. Now, so when we differentiate this one, first 1 over 3, we are going to bring down to multiply. So we have 1 over 3 here. Okay, so after that, right, we have 1 over 3 minus 1, and this gives us negative 2 over 3. Okay, so power reduced by 1, we get negative 2 over 3, and change back to the positive index or positive power. So we have 1 over 3x, 2 over 3. Now for question C, right, we have the function y equals to 1 over x squared. All right, so to differentiate, first we need to change this to index form, which is x to the power of negative 2, right, x to the power of negative 2. So when we differentiate this one, right, the 2, right, we bring down to multiply, right, negative 2 bring down to multiply, and after that we have negative 2, the power reduced by 1, so we have x to the power of negative 3 here. All right, so when we change back, so the negative 3, it becomes x to the power of 3, and we have the negative 2 here. All right, so in this example B and C, now please note that first we need to change the function to the exponential form. All right, so we have to rewrite this as the indices form, index form. Okay, then only we can differentiate. Now the third differentiation rule is called the constant multiple rule. Now, so what does that mean? It means that when we have a number in front of a function, all right, when we differentiate, we only differentiate the x. We do not differentiate the number. Okay, but however, later the number is going to multiply the function of x. Okay, so these are the example. Right, first y equals to 5x to the power of 3. Now as we can see here, the 5 here is a number, multiply x to the power of 3. So what do we do when we differentiate? So when we first differentiate, we are going to differentiate x to the power of 3 only. Alright, the 5, right, we are not going to differentiate. Alright, we just put aside. So when we differentiate x to the power of 3, first the 3, alright, we are going to bring down to multiply. And then we have 3 minus 1, which gives us 2. So it is x to the power of 2. Alright, so and finally we have 5 times 3, which is 15. So 15x squared. Right, so this is called the constant multiple rule. Okay, so let's take a look on question B. Now to differentiate this one, alright, first we need to change the x to index form, which is 2x to the power of -1. Okay, so change the x to the index form. After that, when we differentiate, now since 2 is the coefficient, so we do not differentiate 2, we just put the 2 aside, we differentiate the x only. So when we differentiate the x, -1, we bring down to multiply. And what happened after that is -1, the power reduced by 1. So we have -1, which is -2. And after that, right, we have 2 times -1, we get -2. And x to the power of -2 change to over x to the power of 2. Okay, so let's consider question D now. Now for question D, alright, so we need to change this to index form. Alright, so square root change to index, it will be x to the power of x to the power of 1/2. Okay, so we have 2x to the power of 1/2. So when we differentiate, again we do not differentiate the 2. Alright, we differentiate the x only. So to differentiate the x, we bring the 2 aside. So differentiate the power, 1/2 bring down. So we have 1/2 here. And 1/2 minus 1 gives us -1/2. So we have -1/2 here. So after that we multiply 2, multiply 1/2, we get 1. So we have x, alright, to the power of -1/2, which gives us 1 over square root of x. Okay, right, so for question E, right, again, first we are going to change this to the index form. So we have 1/2. Alright, this one is actually 1/2 to the power x to the power of 2/3, right, because the root is 3, so we have 3 as the denominator. The power is 2, so we have 2 as the numerator. Alright, so power is 2/3. Now after that we bring it up, it becomes x to the power of -2/3. Okay, so now when we differentiate, again according to the constant multiple rule, we are not going to differentiate the 1/2. Okay, we just put this aside. So we differentiate the power here, -2/3, we bring down. Okay, so bring down, and this -2/3, after that we minus 1. So -2/3 minus 1, we get -5/3. So after that we simplify here, 2 and 2. So we have -1/3. And this negative, right, we change the x to the denominator. Okay, so this is actually how we use the constant multiple rule. So the constant multiple rule, remember, it says that, right, when we have a number multiply the x, we only differentiate the x, All right, this number we put aside. After we get the result, we multiply this number with the result of differentiation. Okay. Now, one very important thing is that, okay, we can actually combine the constant multiple rule and the power rule together to solve some of the questions. All right, so as you can see here, all right, so when we have cx to the power of n, we can actually just bring the n down and the n minus 1. For example, if we have 5x to the power of 3, and when we differentiate, so what can we do is we can just write the c is the 5, so we can just write the c, then 3 bring down, all right, x 3 minus 1, which give us 15x squared. Okay, so we can combine the power rule with the constant multiple rule. Okay, we have another rule called sum and difference rules. Okay, it says that when we sum two functions or we subtract two functions and we differentiate, so we can actually differentiate the two functions individually, okay, or we differentiate them separately. Now, for example, for question A, when we differentiate the fx, all right, so we have x to the power of 3 minus 4x plus 5. So when we differentiate, we are going to differentiate this one by one. First, we differentiate x to the power of 3. So when we differentiate x to the power of 3, okay, what happened is that we bring the 3 down. All right, we copy the x, then the power reduced by 1. So we have 3x, 2, all right, 3x squared. So then we have this 3x squared here. Now after that, differentiate the x is 1. All right, so we have, all right, differentiate the x is 1. So we have 4 multiply 1. So it gives us 4. Right, so we have minus 4. And differentiate 5, right, since 5 is a constant, so differentiate 5, we get 0. And we do not have to write it. Okay, so this is the sum and difference rule. So for question G, right, the similar situation. Right, first we differentiate the first term here. So 4 bring down 4 minus 1. So we simplify this 4 and 2. So we have 2, right, negative 2x to the power of 3. Okay, we have negative 2x to the power of 3. And after that, differentiate the second term, right, plus differentiate the second term, 3 bring down, multiply the 3, we get 9, and 3 reduced by 1, we get 2, so it will be 9x squared. All right, finally, differentiate 2x. All right, differentiate the x is 1, so we have 2 times 1, which gives us 2. Okay, so since we differentiate gx, we put g prime x. Okay, now this question C, we differentiate y equals to 3x squared minus x plus 1 over x. Okay, to differentiate this, first we can actually split this into 3 terms. So first we have 3x squared over x and minus x over x and plus 1 over x. So we have square and x. All right, so we have 3x only, so then we have 3x. Then x and x simplified, we have 1 and plus 1 over x. Now after that, we differentiate from here. Differentiate the x, we get 1. So 1 times 3 is 3. Okay, so after that, differentiate 1, give us 0. All right, so we do not have to write anything. Now finally, differentiate 1 over x. Now the 1 over x is actually x to the power of negative 1. Okay, so x to the power of negative 1. So when we differentiate, negative 1 bring down, all right, x negative 1 minus 1, so it becomes negative 2. And so when we multiply, we get negative here, all right, refer to this negative, and x to the power of negative 2, we change this one to 1 over 2. 1 over x squared. Okay, we're going to change this to 1 over x to the power of 2. Okay, so and from here, if we try to make the denominator same, we have 3x squared minus 1 over x squared. Okay, so there are very important definition, when we try to find the derivative of the sine and the cosine function. Okay, so these two definition, we need to actually memorize it. Okay, we need to remember it. So if we differentiate sine, we get cos, and if we differentiate cos, we get negative sine. All right, let's see some example. So differentiate sine, we have cos, so we have 2 cos x y prime. And for question B, y is sine x over 2x over 2. So when we differentiate sine, we get cos, so we have cos x over 2. All right, question C. All right, so we have y equals to x plus cos x. So when we differentiate x, we get 1. Differentiate cos x, we get negative sine x, so we have 1 minus sine x. And for question D, differentiate cos x, we get negative sine x here. So then differentiate sine x, we get cos x, so we have negative pi over 3 cos x. Alright, so these are the basic differentiation rule that we need to remember.